Hello everybody. Please accept my greetings for the day. I am Surajit Das and I have been working in the field of information technology since years. Now I am going to start a presentation pertaining to my master's thesis which has been developed in the domain of health industry. Our research was carried out on the classification problem of the breast cancer. In the broad manner, it can be said that predicting breast cancer via supervised machine learning methods with optimization techniques. Before I start, I would like to convey my gratitude to my supervisor who has inspired me a lot to come to this position, and I would like to give thanks to my other friends, colleagues, and all my well-wishers. Now, let us put some introduction about the breast cancer. Breast cancer, or widely called breast carcinoma, is a disease where the inflammation of breast cells occurs without any controlled manner, and this is the one of the most prevailing diseases that thrives amid the human beings over decades. Every day, it is growing a fatal threat to the world. According to the report published in March 21 in the website of WHO, in 2020, about 2.3 million of women diagnosed with breast cancer. 685,000 deaths occurred globally caused by the breast cancer in the same year. Till the end of the year 2020, about 7.8 million of women alive with breast cancer in the past 5 years. According to the data released by the International Agency for Research on Cancer in December 2020, breast cancer has overtaken the lung cancer and has reached at the top position as a commonly diagnosed disease. Now, let us talk about breast cancer and its industry. Here is some brief information about how the breast cancer influences the health industry. Breast cancer industry is a multi-billion industry. Breast cancer market is valued at USD 22.55 billion in 22 and expected to reach USD 45.94 billion by 2027. Here are some key market players including Pfizer, BMS, etc., who are investing a lot of money on research through strategic partnerships. The breast carcinoma market is segmented in various sectors. For example, therapeutics market, which deals with the various cancer therapies like targeted therapy, hormonal therapy, chemotherapy, immunotherapy, etc. Another important sector is diagnostic market. Diagnostic market is further segmented in the following sector like imaging, biopsy, genomic test, blood test, etc. Currently, the market value are shared in the ratio represented here by the pie chart with different diagnostic segmentations. The region covers North America, Europe, Asia Pacific, Latin America, Middle East, Africa, etc. Further, we can see how the imaging sector's market value changed over the years region-wise. Now, finally, here are some organizations who are working on the AI-powered breast cancer diagnosis with special initiatives. For example, let me talk about Fathomx. It is a Singapore-based digital health AI company which is a spin-off company from National University of Singapore and National University of Health System. As per the report published on 1st September 2021, Fathomx raised a pre-series fund of Singaporean dollar GDP, Singaporean dollar 2.24 million to lead a research related to AI powered breast cancer sector. Now let us talk about aim and objective. The aim is to develop a machine learning ensemble model on the WBCD dataset and to apply some optimization techniques to achieve better performance. Also, to identify the influential factors which contribute to propensity cancerous tumor. The objective is to build an machine-assisted diagnostic system to identify cancerous tumor. Now, let us come to this literature review. In the perspective of machine learning and artificial intelligence, there are numerous researches have been being continued with the subdomain of breast cancer prediction, classification, and risk analysis. This field has been growing as an interdisciplinary field with the collaboration of many international organizations like ICPC, IARC, IBC, ICART, etc. These are the significant researches. Actually, researches reveal that the heterogeneous tumors and its biological properties and the cancer survival prognosis are not only uh, related to only proteomics or genomics, rather it is influenced with multiomics data. This multiomics data sometimes is integrated with histopathological images and clinical data also for better prediction, and different AI techniques are adapted for the experiment. Now let us come to methodology part. So at first, kick off the research, then acquiring the domain knowledge, then gathering data, then data preparations, pre-processing EDA, then feature engineering, then trend test split, Then we are coming to model building part, then k-fold cross validation, and there are parallel steps applying ensemble stacking and applying ensemble blending. And after these three steps, we are capturing the results and we are validating the model and then analyzes the model and we are comparing the result and finally it comes at end. Then this is we are talking about the data preprocessing and univariate analysis. Here count plot and bar plot we can see. Basically we checked whether the data is balanced or not. We found that data is balanced and no missing value found, no variable is uh, all variables are numeric except the target variable, and the descriptive statistics observed, then outlier removed, then distribution plots and other plots drawn. We performed the Shapiro-Wilk test so that to find the normality and the p-value, etc. Then we are coming to bivariate analysis. Here we have done the correlation matrix and some joint plots. Then the models part. Here we have built up two ensemble models. One is stacking, one is blending, and thus base models are logistic regressions, XGBoost, and random forest. We also used PDP and SHARP for the analysis of interpretability, and then we are coming to optimization part. We have optimized the cutoff value and as well as we optimize the weight. So we have used Neldermade and Trust Constructor and for these two optimizations. Next we are coming to this result and discussion part. First is these are the confusion metrics for logistic regression, XGBoost, and random forest. We have enlisted the test score and train score here for every model, and also these train score are average score because these are taken after k-fold cross validation. So next slide we have found the cutoff and f score, cutoff and f score using these two optimization, and we have found the f score is 0.98 for the Neldermade and for the other process is 0.97. Then weights, we found the weights of the ensemble using Neldermade and the other method optimizations, and we have got 0.98 and 0.97. Finally, we are coming to this slide. Here we have discussed SHARP and PDP analysis. In PDP analysis, this variable is being affected in a particular region, but after that the variable is constant, no significant changes found. Now this is the conclusion part. The staking score and the blending score are more or less same, but in blending we can optimize further. There are the scopes and for better result. And this is the recommendation part. We can use Panda profile for EDA. Stratified trendless test split can be used in future. Optimization through genetic algorithm can be used for hyperparameter tuning, and PCA, ICA, LDA, and AE are recommended to reduce the dataset dimensionality. Naive Bayes, SVC, K neighborhood classifiers, AN can also be implemented. And for explainability, we can use lime and noun. So this is the brief presentations of the project. And finally, I would like to thank all of you. Have a nice moment. Thank you.